Welcome, everybody. Welcome, welcome, welcome. Mr. Viteri here. Very excited to be here. Let's get right to it. So, today we're going to be covering Unit 7. We only have 9 units, so we're on Unit 7, closer to the end. And this one's on air pollution. So, let's get to it. So, what is air pollution? Now, that term pollution is a great term to understand. Once you understand the term pollution, we could apply other words to it. Pollution is going to be a term used to describe anything that becomes detrimental to life. It could hurt animals, it could hurt plants, it could hurt humans, it could hurt insects, anything. So once the environment is changed in such a way that it becomes dangerous or it can hurt an individual or an organism, it is then considered polluted. Okay, there are a lot of compounds that could uh, because be the cause of pollution. All right. And then what we're going to concentrate and focus on today is the compounds that are associated with air pollution. Now, so once the air becomes unhealthy, therefore it's polluted. So where does this bad air come from? Okay. Typically, when we burn objects, things are going to go into a gas form. Okay. Or even boiling something goes into the gas form. Okay. So we could think of fires. Fires are going to cause vapors. We could think of smelting. We're going back to smelting. If you remember when we were talking about mining, if we were melting rocks, right? Gold, or we were making a sword like Conan the Barbarian. It's going to give a lot of vapors, and these vapors are now going, if smelled, if inhaled, are could potentially cause some damage. All right, so things like I'm not going to go over the laundry list right now, but things like mercury, lead. These things, when inhaled, paint. These things, when inhaled, can cause damage. Okay, so those are some places that air pollution comes from. All right. Now, certain compounds are more toxic than others and at small concentrations. And so let's really focus on what this word means, ppb or ppm. That stands for parts per billion or parts per million. Now, I'm in this room right now and I'm just inhaling and I don't smell anything. But there could be small concentrations of pollen in here, dust in here, bacteria in here, viruses in here, and they're in very, very small concentrations. So that parts per million would mean, let's say, all the air molecules in here. Let's say there's O2 and there's nitrogen in here, but just let's say the air is 1 million parts, and just let's say there's one particular pollen for every air molecule. So that's how small this could possibly be. And now parts per billion could go up to 200, 300 parts per million. Parts per billion is even smaller. So think of how many concentrations that can be. A way to diagnose this or try to get a visualization is if we went down to the community center and that big pool that they have there, there's a lot of water in there. Imagine putting like 1 can of soda in that water. Now that could be 1 parts per million, let's say. That's going to dissolve. You may not even see it, and it's very, very diluted with all the water that's in there. But that's basically the concentration. Okay, and so I like, the air quality in the United States is really, really good. I've been to Ecuador where as soon as you got off the airplane, you actually smelt some emissions. Depending on where your location is, you'll have better air quality and poorer air quality, specifically here in the United States as well. I know if we drive down towards Newark Airport, there's a lot of refineries there. There's refineries in Seawarren, but there's a lot of manufacturing of goods, and you see smokestacks like this. Smokestacks like this are going to hurt the air quality of a good region. And so a good way to just even know or measure air quality where you live is having lichen present on your trees. If you have lichen present on your trees, it's kind of like an indicator species where it's going to indicate that the air quality is pretty good in your area. And so we do have a lot of lichen on our trees here in Woodbridge Township. So I think the air quality is pretty good here. I know when I drive down to the Newark Airport, there, I do start smelling some sulfur and some other different things that are going on there. And sometimes I see like a yellow emission coming out. Um, so be cognizant, realize that air could affect your health. Let's continue. So there are some natural sources of air pollution, and this would be something like a forest fire, which is going to produce a lot of carbon dioxides, nitrogen dioxides, some sulfur emissions, but not that much in comparison to, let's say, coal or a volcanic eruption. A volcanic eruption is going to be a lot of carbon dioxide, a lot of sulfur emissions, a lot of nitrogen emissions as well. When I say sulfur emissions, I'm going to start using the term NOx, or nitrogen oxide or nitrogen dioxide. There isn't even a nitrogen trioxide. Sulfur the same way, sulfur oxide, sulfur dioxide, and a sulfur trioxide. Typically the trioxides we're not dealing with, we're just dealing with SO, SO2, NO, NO2. Another source of natural air pollution could be pollen. And our pollen is raging like crazy nowadays. If you go to your car and if you haven't washed it in a couple of days, and you just put your finger on it, I bet you could draw a picture because the pollen is so thick. But we're so blessed to actually have all these beautiful flowers reproducing at this particular time. So air pollution is not something that is necessarily just caused by man. It could happen in natural places as well, and certain people have really bad allergies. uh, I'm talking about you. You know who you are right now. That right now you're pretty much on um, some allergy medications because you can't even go outside. And how about a dust storm? A dust storm could also be a source um, of natural air pollution. All right. Now, what are some anthropogenic? So remember when we were using that term, anthropogenic, that means man-made or woman-made. The what are some man-made sources of pollution? Now, this is typically combustion of fossil fuels. Anytime we burn something, there's going to be some potentially toxic vapors. That's why we shouldn't have a fire in our house. You have a fire in your house, you're going to have smoke, right? Smoke is going to build up and people can suffocate in a house. All right. So factories combusting fossil fuels could potentially be a source of some air pollution. And the one particularly we're talking about in this particular slide is carbon monoxide. That's going to be CO. Combustion of fossil fuels, it has some coal here. Cars are also going to produce a lot of air pollution. And power plants need a fuel source, either coal, natural gas, um, or oil, and they're going to also emit some air pollution. All right. So, how can we start to categorize the differences between these air pollutants? Well, we have two big categories here. We have primary pollutants and secondary pollutants. Let's say that in our head: primary pollutants, secondary pollutants. Primary pollutants are going to be a term used to describe a pollutant that is basically made straight off. It's basically made during the time of combustion. Okay. And that could be, in this image here, it's a little cloudy, but that would be carbon monoxide would be a primary pollutant. CO2, carbon dioxide, would be a primary pollutant. You're going to need to know a couple of these. All right. So know carbon monoxide, carbon dioxide, um, and sulfur dioxide, SO2. These are primary pollutants. Okay. And remember how I was telling you about SOx or NOx, NOx? Here's nitrogen oxide and nitrogen dioxide. Typically, these are going to be primary pollutants. They're going to be made as soon as you start burning something. You burn a piece of wood, you burn a piece of paper, you burn a piece of coal, you burn gasoline. Since they're fossil fuels, since they're burning organic material, any organic material, wood, straw, dung, human, anything is going to produce these compounds. These are your primary pollutants. Now, what is the difference between secondary pollutants? Is secondary pollutants are formed by two primary pollutants coming together, or basically they form in the environment. Okay, so some change has to occur. So primary is made straight up, and then secondary pollutants are going to be made by usually the combination of two primaries or some type of chemical reaction later down the road is occurring to make that secondary pollutant. Okay. So please understand that. Now, we're eventually trying to get to acid deposition, aka acid rain, right? And so if we look at this chemical composition here, we're giving you some examples of, let me just move my image here. We're going to give you two big examples of a secondary pollutant, which is sulfuric acid and nitric acid. And so sulfuric acid is H2SO4 and nitric acid is HNO3. Good idea here would be to make an index card to try to understand those carbon, to try to understand the chemical formulas for those and name those. So the way I know it's an acid is because it starts with a hydrogen. So look at all acids are going to start with a hydrogen. So sulfuric acid and nitric acid. If I had to pick one that I really want to know, I'll definitely pick the sulfuric acid. Okay. So how do these form? Well, let's look at carbon, right? Carbon, we all know like wood is made out of carbon. And when combustion occurs and it mixes with oxygen, carbon monoxide will form, carbon dioxide will form. Well, a tree or a piece of coal or some natural gas, they also have some impurities in it, like sulfur. When that burns, it's going to bond with oxygen. And the atmosphere itself, okay, is made out of nitrogen. So when there's immense heat, a chemical reaction binds that nitrogen to that oxygen. And so therefore, that's how you get your pretty much your primary pollutants, right? Now, as those primary pollutants go up into the atmosphere, let's particularly talk about sulfur dioxide. Sulfur mixes with water and will make sulfuric acid. All right. And when I say water, I'm meaning water vapor. All right. So once again, here we go. Primary pollutants are going to, some examples would be carbon monoxide. Index cards would be really, really good here. Nitrogen oxides. Let's introduce this term here, PM, which is a particulate matter. Now, particulate matter is a category. It's not necessarily a particular element. It can be, I know I start fires with a paper towel sometimes. And then sometimes like the wind catches a piece of that paper towel and it starts flying around. It's just a very little piece of ash that's basically being moved. That would be associated as particulate matter. Pollen can be associated as particulate matter. Uh, Asbestos can be associated as particulate matter. Particulate matter typically just means a particular size of a substance that is floating around in the air. Okay. When we use a mask and anything that's getting caught on that mask has a particular size, the larger objects that are getting caught on that mask would be associated with particulate matter. Okay, so that's particulate matter. SOx would be that sulfur oxides like we talked about, and VOCs, which we'll talk about later. Volatile organic compounds. These are things that you inhale that could be potentially dangerous to you. Give you an example: spray paint, markers, gasoline vapors. Some people say they like that smell. It's a bad smell, killing brain cells. Okay, VOCs is a term. These are all primary pollutants. Okay. As far as secondary pollutants, I told you two already. One being sulfuric acid, another being nitric acid. But a very popular one, which I've seen in multiple exams, is ground level ozone. Here we go. We're going to start confusing you, and you need to pay really close attention because there's some misconception alarms going off in my head right now. In this case, ozone is a great gas in the stratosphere. It protects us from UVB radiation. Amazing. Okay. However, if I inhaled ozone in the troposphere, and that means because we live in the troposphere. If I inhale it, it's actually a poisonous gas. And if I had asthma or emphysema or some respiratory problems, COPD, then that could exacerbate the issue. Ground level ozone, bad. All right. Stratospheric ozone, good. Okay, so depending on where it is, it's good or bad. You should remember the chemical formula for ozone, which is O3. Now, during it's a secondary pollutant, and it's a very famous secondary pollutant. So I want to spend some time on this. During the combustion, typically of cars, VOCs plus the oxygen in the atmosphere, these two compounds plus the sunlight, so it has to have immense sunlight. So the sunlight causes complex chemical reactions in VOCs and the oxygen in the atmosphere, which then binds O3. And now when you have tropospheric ozone, that causes an issue. So the chemical formula is O3. It's tropospheric ozone, and it has the help of the sun, which creates this. In computer labs or photocopying machines, that mimics the sun, and in a copy room, it should be properly ventilated. But if it isn't properly ventilated, you could have a higher ozone concentration in there. I think that also our projectors, overhead projectors with the very bright light bulb, is also causing a chemical reaction between the oxygen and VOCs in the room, and ozone could be made there as well. So proper ventilation is a must for these. Ozone gets so bad in certain urban areas that in Jersey we have something called an ozone pass. And this was something cool when I was doing some work at NJIT. Um, I could take an if you go to the college and you buy these special tickets, and when you buy these tickets, you can travel anywhere in New Jersey using the trains for like $2.50. And so getting to Newark, I think, cost something like $10. But I was able to buy these tickets, and instead of driving my car, I would use this ozone pass. And so the conductor, most of the time they wouldn't check, but sometimes they would check to see if it is an ozone day. So what is an ozone day? Typically in the summer, um, they classify the day as either being ozone day or not. On really hot days, specifically in our area, in an urban area, there's a lot of traffic. So therefore, there's a lot of ozone being formed. In order to reduce that ozone, they wanted to encourage people from taking the train. Since I was the only one traveling, I could take that train, and a monetary incentive was $2.50. I'll get into the city, and $2.50 I get back. But you could use those ozone passes to actually get all the way down to the shore and come back, which would probably be a $20 or $30 ticket, because that ticket right there is something to look into. So if you do go to a potential college and you do take um, uh, the train, I would definitely look into that. Matter of fact, you could possibly get all the way into New York City with that ticket, because, right, we take that New York City. Anywhere in New Jersey, you could probably get it. Or you get to Newark, and then you probably have to take the PATH. I don't know if the PATH train takes that, but something to look into. Look into Ozone Pass. Okay. Okay, so let's recap what we just talked about here. Primary pollutants: carbon monoxide, nitrogen oxides, sulfur oxides. Okay. Secondary pollutants: sulfuric acid, nitric acid, and ozone. Tropospheric ozone. Very important one. Tropospheric ozone, bad. All right. All right. So now here's a good image of that sulfur oxide. So sulfur oxide's being formed. All right. And now it's going to mix with H2O vapor like clouds, and it's going to form sulfuric acid. Right. Another thing that could form is here nitrogen dioxide. Here we go, mixing with water, and now we have nitric acid. So if we are burning fuels that have a lot of sulfur in them, particularly coal, dirty coal, okay, so that wouldn't be anthracite, it wouldn't be subbituminous, it wouldn't be bituminous, it would be lignite. If we're burning a lot of lignite, then there's a lot of sulfur in the atmosphere. The other day, I sent you a picture of like a gas station with the sulfur that said it has low sulfur diesel. I didn't even know diesel fuel itself could have small emissions of sulfur as well. So, anyhow, so that technically means that trucks, when they're running and they're burning diesel fuel, that not only are they making carbon monoxide, carbon dioxide, they're also producing sulfur dioxide. And so, in a way, trucks are contributing to acid deposition, acid rain. All right. So here we go. So we'll have sulfuric acid and nitric acid, and that's going to come down in the form of rain. All right. Now, acid rain can cause lakes to get more acidic. Okay. It could also destroy the foliage of plants, destroy the plants. If you destroy your plants, you can kill your crops. It could also cause statues to erode. All those things will occur due to acid deposition. Here we're talking about nitrogen dioxide. It's the same thing. Where's the nitrogen? There's 80% of the atmosphere, of our troposphere or atmosphere, is made out of nitrogen. When that binds, or basically combusts, and we have H2O in the air, in the form of clouds and water vapor, that's going to form nitric acid. The same thing will occur. Now, remember, as lakes become more acidic, what happens to the pH? Does pH go up? pH goes down. pH goes down. And so if the pH goes below 7, it's more acidic. If it goes above 7, then it is more basic or more alkalinic. All right. All right, and I believe that's going to be the end of our lecture today. Hopefully, you learned something. Hopefully, you understand how dangerous tropospheric ozone is, and you understand that three secondary pollutants would be sulfuric acid, nitric acid, and tropospheric ozone. All right, I hope you enjoyed this, and I'll talk to you later.